Okay, IED, what we're going to be doing today is we're going to be doing activity 1.3.2, part 3. So this is going to be the third part. We've been taking this section and we've been breaking it down, and now we're on to task number 2, which is going to be our part 3, which is modeling the slide block. So it says begin modeling your assigned slide block using the annotated multi-view drawing of the slide block provided by your teacher. It says pair 1 and pair 2. So if you're digital, follow along with this video. We're going to be doing the pin slide block and not the screw side block. Slide block, not side block, sorry. So that way we're not going to have to worry about it. You're going to be doing this on your own, but that's okay. We're going to try to work our way through this together for the slide block. So what I'm going to do is the first thing I'm going to do is let's see here. We need the actual slide block. So it says provided by the teacher. Oh wait, I'm the teacher. So here we go. And this will be on the assignment as well too, so that you can see the multi-view drawing of the slide block. And here is what we have. Take a look at the numbers. They're very precise numbers. I see a lot of things to the nearest thou. The good thing is I don't really see any fractions here, so it looks like we can probably make this an on shape. Now, I've got to think about how I want to do this first and foremost. Do I want to start with the left and right? Do I want to start at the bottom? There are lots of different ways that we could 3D model this, so it pays us to take a step back at this moment and look at the diagram and actually think about how you're going to create this drawing first before you actually create the drawing, or before you actually create the 3D model. So I'm looking at this. The front view is the one on the bottom part. It has a height of 0.813 inches. It is 1.75 inches across. I'm looking at the top view above it, and I see it really just kind of looks like a rectangle, and that rectangle has been chamfered a little bit. I also see that there is some distances here that on the front side that the bottom height is 0.375 and the top height is 0.813. That'll give us the difference between those will be the height of the other one, so we can use that to our advantage too. So, just kind of taking it easy for the first part, not specifically rushing into things. I'm also looking at the side, and I see that there's this hidden line just right there. When I look at the top, though, there's a hole, and that hole goes through. And I know it goes through because in the hole notes over here it says diameter 0.165 through. So I know that hole goes all the way through. But I also know that there's a counterbore here, and that counterbore is just a tiny little bit bigger. We're talking like 1/100th of an inch bigger, so it's not going to be that large, but in the model, that's probably what we should do. Since we don't necessarily have a specific hole command in OnShape that I've taught you yet, we're going to probably just do two extrusions, a big extrusion for the hole and then a smaller extrusion for the hole. And then from there, we should be able to work our way from there. So I don't know. We're gonna call this pin slider block. So we're gonna go into Onshape and we're going to create a file. So I'm gonna go ahead and type in Onshape and we'll get ourselves logged in. And once we sign into Onshape, we'll go ahead and start making our part. I'm gonna move this over to the side as a reference. And you can always go back to that part of the video to see what's going on. So, all right, so I've got this thing called projects. I'm gonna click on the projects folder, and I've already got one that says mask holder. That's from my masks for the COVID stuff. So I'm gonna create a new folder, and I'm gonna call it Trammel Toy. And I'm going to click on that folder and I'm going to create a new document. And I'm going to call this one Pin Slider Block. Okay, and we're going to hit the OK button. And it'll start loading up our file. we're going to get a blank workspace here, and the very first thing that we want to do is, I'm going to go back over here to this. The very first thing that we want to do is we want to create, start from the bottom, and we're going to work our way up. So we're going to create a block, and we're going to go up 0.375. I'm going to use my dimensions that I have for the rectangle, and then I'll chamfer some sides out. So it looks like we're going to go 0.734 across and 1.75 in the horizontal direction. So back in Onshape, I'm going to click on, ooh, that's the wrong one. Here we go. Sketch, go to top. I'm going to click on top so that we're sketching at the top. And I'm going to go to the top view so that we can actually see what we're doing. I'm going to make a rectangle, and this rectangle is going to be 0.734 and 1.75. So I'm going to click and I'm going to type in 1.75, enter, and then I'm going to hit 0.734, enter, and that's going to give me the base of the block. And then I'm going to say, yeah, that looks good. I'm going to click on this corner to get the isometric view. And then what I'm going to do is I'm going to hit the extrude button, and I'm going to extrude up, and I'm not going to go the whole length of the rectangle. I'm only going to go up 0.375. So I'm going to click 0.375, and I'm going to click OK. So far, so good. No disasters yet. Next thing is we want to try to use the chamfer, and I'm looking at these diagrams, and does it give us any idea of what the chamfer is? Ah, yeah, look, when you look down at the bottom view, I'm going to move back over here. When you look down at the bottom view, these chamfers are 0.125 by 0.125. So any one of these features are going to be 0.125 because it says TYP, that means typical. So if you see a chamfer, the typical chamfer is going to be 0.125. So we'll go back over here. We're going to use our chamfer option. We're going to click chamfer, and I'm going to make sure that my distance is set to 0.125. And then I'm going to click all the way around. So I'm going to go ahead and set up my chamfer. 1, 2, 3, and then to move around to the other side, we'll do the fourth one. 1, 2, 3, 4. And that looks good. So I'm going to click the green check mark. And that actually already starts to look like a pretty good base of the shape. The next thing that we're going to need to do is we're going to need to make another base on top of it. And this one looks like it's going to be, let's see here if we can actually find the dimensions for it. I'm going to go back over here so we can see. Let's search and let's find out. I see that there is, this whole distance is 0.734. And I know that the distance here is 0.141, and I know that the distance on the other side is 0.141, so that means that this distance in between here, oh, they didn't give us the number. That means that we're going to have to do a little bit of math. So we're going to have to subtract 0.141 twice from 0.734. So let's grab a calculator and let's see if we can get that going. Where is my calculator? I'm going to dig around here on the desk and see if I can find it. There we go. And cell phones also can count as calculators too. All right, so I'm going to do 0.734 minus 0.141 minus 0.141. Hit enter. That comes out to 0.452 inches this away. And the other direction is going to be the same distance. It's going to be 1.75. Okay, so I'm going to go back into my Onshape. I'm going to click the top button, get ourselves viewed over here a little bit, and we're going to make a rectangle. So I'm going to go sketch mode, click sketch, and then click on the face that you're going to make the sketch on. And then we're going to make a rectangle. Now there's a couple of different options that we can do here. There's a corner rectangle and there's a center point rectangle. And in this case, I would probably recommend that you guys use the center point rectangle, and I'll show you why. You can use the corner rectangle to go from one corner to the other, from like here to here. But the center point rectangle, I think, should actually give you your center point. So if I move over here and I start off in the middle right here, and I can use this trick to kind of get my guide points. Remember, you need to like move your mouse over here and then move your mouse over here, and it'll give you the center. So I'll say, hey, that's the center, and I'll make my rectangle go up, and it looks like we're going to um, click. We're getting close. So I'm just gonna, I don't think we necessarily want them to lock in place. I want them to lock in place here, but I'm not gonna snap them into place up on the top. And the reason why I'm not gonna do that is because it says that the length from those two locations is 0.484, and I just measured out that it was 0.452. So even though on the diagram it kind of looks like they're like straightly connected to each other, they're actually not. So I'm gonna just snap it to the grid on this side, and then that's gonna give me 1.75 for one of the measurements. So I'm gonna hit enter for that one, and then the other one is gonna be point. Let's see here, 452. So I'm gonna type in 0.452. It looks like I hit a constraint issue, so that might have been a little bit of a problem for me. I'm going to try to get rid of those red marks. They don't make me feel very happy. So I'm going to go back. I'm going to try again. I'm going to click on the rectangle. I'm going to go to a center point rectangle, and I bet it's because I over constrained the sketch. So I'm going to click on the center, and I'm just going to click. I'm not going to snap this onto grid. I'm just going to click. Okay, so then we should be able to type in 1.75, and then I'm going to hit enter, and then the other one is 0.452. I'm going to hit enter there. So it looks like they're really closely connected to each other. So there is our rectangle, and we're going to extrude that up. The distance from there, we're going to have to subtract 0.813 from 0.375, and see what that comes out to be. 0.438. So I'm going to hit the green check mark to prove that we're all okay. We're going to go to isometric mode, and we're going to hit extrude. We're going to extrude this up, and hopefully it's going to work. It seems to. It's going to go up to 0.438, and we're going to hit enter. Okay, so we got a second part of the block here. Looks decent, so I'm going to go ahead and hit the check mark. There are some chamfers on this side as well too, and since it said typical, those chamfers I'm going to assume to be 0.125. So I'm going to make sure that my distance is 0.125 by hitting the chamfer button, and I'm going to chamfer these four sides down. One, two, that looked really big there for a second. Three, and then go around to the other side. Other side again. There we go. Four. And then I'm going to hit the check mark. I'm going to say, you know what, that looks okay. I'm going to hit that check mark. So now we're starting to get kind of what our shape looks like. Go back to our regular plain Jane isometric view. Okay, I mean that looks reasonable. There are a couple of other things that we have to do though. I'm looking at the structure, and it looks like there's some fillets that they put in as well. Yeah, there's some fillets at the top. So, and the reason why I say there's some fillets at the top is that this is going to be rounded. I'm going to look at the, let's go back over here if it'll let me. There we go. We've got the chamfers taken care of. There's 1, 2, 3, 4, and then on the other side there's 1, 2, 3, 4, and that part looks good. We need to get this hole drilled, so we need to add that feature to our shape, and then we also are going to need to make this fillet on the left side and the right side. And it says that this fillet is 0.25 typical. So let's go ahead and do that first. I think that's going to be an easy thing to do, easier than the hole. So I'm going to click the fillet button, and I'm going to make sure that I have a radius of 0.25, and we're going to click on this edge. Click on this edge on the side, and it should make a fillet that goes around the side. And then on the other side, I'm going to click the fillet button again. There we go. And I'm going to click the check mark and say, hey, you know what? That looks decent at least. I think we're following the guidelines. Let's see. I'm going to look at this compared to my sketch. That, looking pretty good. Looking pretty good. We need a hole in the top though, and that's going to be our last point that we need is we need a hole in the top. So I'm going to click on the top, and we're going to make a hole, and it's only going to go down. I'm going to look at the hole notes. So the hole notes tell me that it is a diameter of 0.165 inches and that it goes all the way through. So I don't know, let's go ahead and do that first. So I'm going to go back into sketch mode, and I'm going to say, all right, so we've got a hole of 0.175. So for a hole in Onshape, usually like Inventor and Fusion 360 have these nice little hole options, but I think in this case, we could do it here. We could use the hole button if we wanted to. You know what? Let's do it. Let's do it. We're not going to make a sketch. We're gonna be civilized here. We're going to click the hole button. So I'm going to click hole, and we're going to try to place our hole on a sketch. Okay, so we're going to, oops. Looks like we're going to have to actually call out a hole first. So let's make a sketch and let's make a point for the hole. So this is going to be a point. So there's a whole lot of different options up here. We don't really want to make a line. In this case, we just want to make a point. So I'm going to click on point. And if I use my little trick to get the halfway marks for each one, I should be able to get the middle of this. It should snap into place. So I'm going to make a little point there. And we'll see if this works. We'll see if we can actually make our hole this way. I've never used the hole button before in Onshape. This is kind of this is a new experience for me. But I'm gonna be civilized. Hole. And then we're gonna click on the dot. It works. Okay, so this is gonna happen here. So from here, we're gonna be using that dot that we created on our sketch point, and we're going to make a, let's see here, we can change it. Look up here where it says simple, click on the menu, change that to counterbore. Oh dear, that's a gigantic counterbore. Let's follow the directions that it says on the hole notes. So the hole notes say that the counterbore is 0.177. So the counterbore is this guy, so 0.177, and I'm gonna hit enter on that one. Okay, now it's throwing a fit because the counterbore is actually bigger than the hole, the bore size. So the actual hole is 0.165. Hit enter. Okay, that's actually working. And then the actual depth, we can just say that it goes down. We can type in, hopefully, if we can type in through, maybe that'll work. No. Let's just use the whole distance of the part. So it says that it's 0.813. We're going to make a through hole. So 0.813, and then click on that. You should be able to see through your object now. So if we make our hole, it should actually go all the way through. Can I see it on the other side? I certainly can. Okay, so we have our through hole, and it's counterbored using the hole button. That was kind of fun. So I'm going to click on the green check mark. Everything looks good there. And now we're going to double check, and we're going to look through the entire drawing and see if there's anything that we missed. I see that we've got the chamfers. I see that we've got the hole with the counterbore, and I see that we've got the fillets on the side. So there are, if you count the chamfers as one feature, there are, I guess we should probably count them as two different ones because we did it as two different operations. There's a chamfers on bottom, there's the chamfers on top, there's the hole, and then there's also the fillets on the side. Okay, so I think that's going to make our pin slider block. There we go. It has been created. That would be how you're going to 3D model this. Good luck to you guys on your dimensioning, and hopefully it will, or good luck on your modeling, and hopefully it works out okay. If not, let me know if you've got any questions. Work through this video, and we'll get it done. Good luck.